Everything I'm about to cover in this video is the kind of basic information and terms and like a glossary index of what you need to know as an author who wants to use AI. A lot of even experienced people who write with AI don't understand a lot of these terms that I'm going to be sharing with you today. So I want to make sure you have all of these systems and terms in mind so that you can understand how AI works and how you can help it best serve you as an author. So let's dive in. The first thing that I wish more people understood is the difference between a large language model or LLM and a tool like a chatbot or another what we call wrapper tools. And to help with this, I like to use an analogy of electricity and an appliance. You can use electricity in a variety of different ways, obviously. If you're in your kitchen and you have a food processor and a microwave and a blender, all of them use the same electricity, but they use it in different ways. And in this case, the large language model is like the electricity. It's the raw power that is creating the results that you want. However, you can have a tool which is similar to the appliance that uses that power in unique ways, and it might be more useful for a writer versus a coder or what have you. So you might have a wrapper tool that's specifically geared in a workflow format for someone who wants to code. And you might have another one that uses the same large language model that is using it for writing or whatever the case is. And even chatbots, which we often think as being synonymous with an AI large language model, things like ChatGPT or Claude, these chatbots are actually wrapper tools in themselves. They are actually really simple wrapper tools that all they have is a simple chat interface and maybe a few other bells and whistles. But if I go to say ChatGPT here, you can see up here in the corner, I can select between different large language models. ChatGPT is not the same as a large language model. It is simply a tool that incorporates a large language model into it like an appliance uses electricity. Now, where this metaphor breaks down a little bit is the fact that there are multiple LLMs, and as far as I know, there's not multiple types of electricity, right? That slight difference. And each form of electricity, each large language model kind of has its own strengths and weaknesses. But by itself, a large language model needs some kind of tool built around it in order to really interface with it effectively. Otherwise, it's just a simple prompt and a response. It doesn't have memory. It doesn't have a whole lot of features. All right, the second thing I want to make sure I get across to you is the difference between regular models and reasoning models. Now, this is a relatively new development, at least new in the world of AI, where we started to get these reasoning models that think before they give you an answer. And by doing so, they actually give you usually higher quality answers, and they're particularly good for any kind of task that involves reasoning or, something that a human would actually spend time to think about it. In the writing world, the best cases for reasoning models are things like editing, because before, when you had a large language model, it wouldn't necessarily give you good advice about your book. If you gave it your book and said, hey, please edit this book for me, it wouldn't necessarily do a good job because it would give you stuff that sounds like what an editor would say, but it wasn't able to actually analyze and think and make decisions based on the book that it's reading. It just gave you stuff that sounded correct. Now, a thinking model, while not perfect in that regard, is much better at actually thinking through what may or may not be a problem with your book, and it's able to give you much better answers. There are other useful applications of thinking models that are usually good for brainstorming or outlining, anything that requires a little bit heavier thought, they're particularly good at. But there are still really good use cases for non-reasoning models. Particularly, for some reason, the actual writing of prose tends to be better, or at least the same for a cheaper price, as the reasoning models. So something that I recommend for pretty much all authors is this idea that you should test out which large language models do what. Because not only are they all different and they have different strengths, but you have your reasoning versus your non-reasoning, and you should definitely check out with every prompt that you have that you use regularly, you should definitely test which one is better for one or the other. All right, the next thing I want to be clear on is what is a context window and a token. These are terms you'll hear a lot around AI, and let me explain them a little bit for you. First, if we come into OpenRouter, which is a tool you'll see me use. It's not really important for this video, but in OpenRouter.ai, you can kind of look at pretty much all of the large language models that are publicly available on the market. Not everything, but the vast majority. And so if we look at one of them, just whatever's here, you'll see it has a 96K context window. If you look at others, like let's look at some of the big ones here, like Llama 4 Maverick has a 1.05 million context window. Now, it just so happens with Llama 4, like I wouldn't trust this based on reports I'm hearing, but technically it has that big of a context window. What that means is that it can process, in this case, over 1 million tokens in its prompt. So you can give it an enormous prompt with 1 million tokens. It'll be able to read everything and understand everything in theory within that prompt. So with a 1 million context window, that's actually really large. In theory, you should be able to have it, like you could have it read all of your organization's documents, all of your books, whatever, and it would be able to understand all of that. Now, in some cases, that isn't always the case. It doesn't really turn out that way. There's this thing called the needle in the haystack problem, where if you give it a whole bunch of stuff, it actually gets worse at identifying small bits of information, kind of like a human would, honestly. But regardless, you should be able to give it a massive amount of context in this case and have it understand that. But first, we have to understand what exactly is a token. Because a token is not the same as words. This is not the same as 1 million words that it can understand. A token is a specific unit that an AI uses to read text, and not all large language models use tokens in the same way. If we go to this tool developed by OpenAI, you can see how the OpenAI models look at tokens. So if I just like copy this text here and just place it in here, we can now see exactly what these tokens look like. And so you might have, a lot of them do translate to single words, like, language models process text using tokens. Those are all individual words are processed as one token. But then we have the comma is also a single token. You'll see punctuation is often a single token. But you also have words like this. OpenAI's is actually 3 tokens. There's open, AI, and then the apostrophe S. You'll also see other words sometimes split up. So over here we have tokenized as 2 tokens right there. And in general, so that's just the way it works. So sometimes it splits words up. Sometimes you have a single word per token. Sometimes you have punctuation function as a single token, etc. So the rule of thumb that's pretty widely considered in AI circles is that if you have, say, 100 tokens, that's roughly equivalent to 75 words. So if you look at this million token context window, you can assume that you can fit in at least 750,000 words into that context window. So that's enough for several books that you could put in there and have it read. Now, once again, the needle in the haystack problem results in, if you give it too much context, it actually performs worse. In general, I'm sure that will get better over time. It already has gotten better over time. I would say a standard context window that you'll see on a lot of models is about 200,000. That is plenty for any of the use cases that I have. Usually my prompts do not exceed 15 to 20,000 words. So all I would need is a good, 50,000 context window to feel safe there. I definitely don't need this $1 million context window for my needs as a writer. And if you are putting in entire books into an AI to read, I would be skeptical of the results you're going to get from that. You will get better results by having AI summarize each chapter individually and then taking that summary of your book and using that in your context, because it'll be fewer words, but still get the point across of your book if you want it to understand the context. So say you're writing a series and you're writing book 2 and you want to make sure it understands what happened in book 1, don't put your entire book 1 into your context window. Not only will that dilute the prompt a little bit, but it will also cost you a whole lot more money. So I would just summarize that book, summarize each chapter individually, and then provide that summary in the context. So little tricks like that make it very easy. All right, next thing I want to talk about is temperature and other AI parameters. So if I'm in the OpenAI playground here, this is something that you cannot do inside of ChatGPT or most other chatbots. You have to do this inside of their own API, which you don't really need to understand right now. I will do more videos about APIs later, but you can think of an API as the cord that connects the appliance to the electricity, to the plug, right? So we have ChatGPT, but then we also have OpenAI's Playground. One of the benefits of this is that you can select a bunch of other models that are not available in ChatGPT. So if we select one and then select these little settings right here, you'll see it actually gives us temperature, max tokens, and top P. If we go to back to Open Router and set up a chat here, let's just open a new chat. We'll pull in just a random, let's do Gemini 2.5 Pro here, and then click these three dots and then go to sampling parameters. You see even more. So we have max tokens, temperature, top P, top K, frequency penalty, presence penalty, repetition penalty, min P, and top A. Most of these you do not need to worry about. They don't really have much of an effect, or at least a desirable effect on your words. But there are some that you should probably play around with, especially if you're not getting the results that you want out of the prompts that you're giving AI. First of all, max tokens. This one is the most straightforward. This one is just like how many tokens can it read? So say it has that million token window. In this case, it doesn't, because no, it does, because this is Gemini 2.5 Pro, which does have a million token context window. But let's say you don't really need that. You just want to bring it down to like say 100,000 or 75,000 or something. Like, you can mess with that. Chat memory, you won't see this everywhere, but here in Open Router, this is just showing you like how far back the chat goes. This again will save you money if you are having really, really long chats, but it will result in the AI forgetting some of the older chats if you set this too low. So you can set this like pretty much to 420, which is the top here. So your chat can go as far as 420 responses before it starts to forget. Then we have temperature. Now, this is probably the most important one that you will look at. And temperature, a lot of people call it the creativity meter. It's not exactly a fair comparison because it's a little more nuanced than that, but you can essentially think of it in that way, that the more we turn this up, the more creative it gets. And the more we turn this down, the less creative and more predictable it gets. Now, sometimes you want predictability. Sometimes you want, if you have a certain automation and you want the results to always be the same kind of response, you can turn the temperature down and it will get more predictable in its responses. But sometimes, especially as authors, when we're trying to write something, we want it to maybe be a little bit more creative. And so sometimes tweaking this up just a little bit can be useful to test to see, is it actually going to write better when you do that? Now, the problem is if you raise this too high, it starts to just become gibberish, because what's happening is large language models are predictive models. They use probability to determine what word should come next. And the higher you send this temperature dial, the less predictable it's going to be. So it's going to start to throw in some words that maybe weren't necessarily the most logical words, but in some cases you might want that. But if you turn it up too high, it's just going to turn into gibberish, and you don't want that either. So it's something to play around with. Most of the time I see people keeping it within like a 0.3 before or after. By default, most large language models start at 1, but you can bring it down to like 0.7 or up to 1.3, just kind of in that range to be more or less safe without it turning into gibberish or anything like that. Top P is similar. So top P, if you lower this top P, it makes the responses a little bit more predictable. And this is because it's actually restricting the number of tokens that the model is using. So if I brought this down here to like 0.5, that means half of the words that could be allowed are not being allowed. So usually I keep this at the top. Maybe you'd bring it down just a little bit so you start avoiding some of those really flowery, overused words, and instead use a little bit more predictable words. But that's just another thing to predict. Top K I don't really deal with. Frequency, presence, and repetition penalty are all somewhat useful because these kind of determine how frequently your AI is going to be using certain words or ideas. And so playing around with this, if you want to, reduce repetition, can be another useful one. But again, some of these are very subtle. I wouldn't necessarily play around with these too much unless you're really an expert at AI and know what you're doing. The one you are most likely to use the most is this one, temperature. And I do recommend you play around with temperature just to see which one is best. All right, last but not least, I want to talk about the difference between a system prompt, an AI response, and a user input. So we often talk about prompts, right? Like, for instance, in my Story Hacker Silver group, I have a bunch of prompts that I've given people that are usually just like, most of them are just a single prompt. You enter it into a chat bot and it gives you a response. But there's actually a lot more nuance to prompting than that. And sometimes your prompts can get a little bit more complex. The prompts that I have in my Silver group, which by the way, you can check out below, is I have some prompts in there for Novel Crafter. Novel Crafter splits things up into multiple parts. So it's not just one prompt, it's actually one prompt split into 3 groups. And those 3 groups are system prompt, AI response, and user prompt. So to show you that here in Open Router, let's just pull up Gemini 2.5 Pro again. And you have right here, when you click on these 3 dots, you'll get this little box that says system prompt. Likewise, if we go here to OpenAI's dashboard, you can see there's a box for the system message here. And actually, ChatGPT, if you're using ChatGPT or other chatbots like it, there is a feature in most chatbots that give you similar results as the system prompt. And you can do it by creating a custom GPT, or you can go here to customize ChatGPT and enter in information here where it asks you, like, what traits should ChatGPT have? And then you can put in style information, different things in here, and it functions much the same as a system prompt. But let's go back to Open Router so I can show this off. So a system prompt is essentially the things that you want it to always know. So if you have a regular task that you want AI to perform, you put that in here. For instance, a really simple version of a good system prompt that I use all the time is I just have in the system prompt, I say, when I give you text, I want you to summarize it in 1 sentence or 1 paragraph or whatever. In that case, so in fact, let's do that right now. When I give you text, summarize it in 1 sentence. And then I just click out of this. And now anytime I give it text, it's just going to automatically do what I asked it to, because it always remembers that that is the way it must always behave. So the system prompt is essentially establishing the parameters that it must always do. Now, if I let's go to my website. So let's just pick one of the articles on my website and just copy this entire thing. Nice long article. And we go to this and paste the whole article in there. It knows, because it has the system prompt, that it now needs to summarize this in 1 sentence. Now, it so happens that Gemini 2.5 Pro is a reasoning model, so it did a little bit of reasoning here that you can look through. But here it is, the sentence, the single sentence summary, where it says, this guide provides writers with a detailed 4-act beat sheet for plotting cozy mysteries, covering essential story structure, character development, and genre conventions to craft a compelling whodunit. So it did what I asked. Right? So that's the system prompt, and it's probably the most important on this list. However, there are 2 other prompt components. Let's just get rid of this system prompt for a minute. Say we don't really have a specific task that we want the AI to do all of the time. We just want to provide it with a simple chat response right now. So we just want to provide it with a simple question and have it answer us in a simple way. So there's no system prompt at work here, but let's just say, give me the lyrics to Mary Had a Little Lamb. This right here that I've just entered in is the user prompt, and it's generally the thing that we're most familiar with prompting. It's the thing that we ask it to do, where we give it a task. And a lot of time we put all of our data, all of our info into that single prompt, when it might be better to split up portions of that prompt into the system prompt. Like, for instance, if I'm writing a book and I want the style to be relatively consistent throughout everything that I do, I put the style prompt and maybe examples of the type of writing I want, put that in the system prompt, because that's the stuff I want it to remember all the time. But then in the user prompt, I give it specific instructions for that specific part of the scene that I want it to write next. So that's the user prompt. It's the most straightforward. I think we all understand how that works. And now the response that it gave me this is the third component of a prompt, and that is the AI response. Now, you might think that's not a prompt, Jason, that is a response. And while that's true, there is, in some cases, for instance, if you're here in Open Router, I can actually go through and edit this. So I could edit this and, say I don't like the style of the response that it gave me, I can rewrite it myself. And then after I hit save, it will think that my edited version is what it said. And so one of the unique things that a lot of people don't take advantage of with AI is the fact that if you put data into the AI response, or you edit the data from an AI response, then what it gives you next, if you say you're continuing on with the next part of your scene or something, it will better match what you saw in its first response. So let's say rather than asking for lyrics of Mary Had a Little Lamb, I just ask it to write a part of my scene, but there were some bits in there that I didn't like, and so I changed the wording. I edited it pretty heavily to make sure it sounded like I wanted it to sound. And then I asked it to write the next part of the scene after that. Well, it will look at what it wrote in the past, and because it thinks that it wrote that, for some reason that helps it to be more effective at writing the next bit. And so that's just something to keep in mind. Anyway, I hope these tips have been super useful for you. Let me know in the comments if you want to see anything else like this, any other things about AI that confuse you. I'll be sure to try and take a look at those. And in the meantime, go ahead and check out my groups down below. My silver group is really low cost. It's a one-time fee. You can get all my prompts and all my frameworks in there, plus access to a really thriving community with thousands of members at this point. And then there's also my gold group down below, which is on a wait list right now, but you can go ahead and I'll be opening that pretty soon. So go check that out, and I will see you in the next video.